Hello viewers, in today's class we are going to discuss yet another important and conceptual problem from limits involving greatest integer function, right? And here we are going to solve this limit, that is limit x tends to minus infinity, and here we have the greatest integer of tan inverse x, right? So here we'll solve this limit by using the method of substitution, right? So let us substitute here, say t is equal to tan inverse x, right? So here we'll make this substitution, t is equal to tan inverse x. So x is equal to tan of t, right? Okay, now here we see that x is tending to minus infinity, right? So when x tends to minus infinity, then t tends to minus pi by 2. Why? Because see, the value of tan of minus pi by 2 is equal to a negative of tan of pi by 2, right? And tan pi by 2 is not defined, that is minus infinity, right? So when x tends to minus infinity, then t must tend to minus pi by 2, right? So let us now apply this substitution to this expression. So now the limit becomes a limit t tends to minus pi by 2, right? So here for x tends to minus infinity, now we can write t tends to minus pi by 2, and we have the greatest integer of tan inverse x, and tan inverse x is t, right? Now when t tends to minus pi by 2, the value, what is the value of greatest integer of t, right? So what we will do here, we'll take t is equal to minus pi by 2 here, so we have greatest integer of minus pi by 2, right? Now we know that the approximate value of pi is 3.14, right? So here we have minus 3.14 over 2, that is equal to minus 1.57, right? So now the greatest integer of minus 1.57 is equal to minus 2, right? See, here we have minus 2, here we have minus 1, here we have 0, right? So minus 1.57, it lies somewhere here, right? So this is the minus 1.57. So the greatest integer of minus 1.57 is equal to minus 2 by the definition of greatest integer function, right? So the value of this limit is equal to minus 2, right? So this is how we can solve these type of limits.